All right, let's divide. We need a 3 by 2. Cubed p squared negative 5p squared. Looks like I need negative 10 p squared. Negative 10p, 50p, negative 10 again. Negative 10p, 10, 50. 44 minus 50, negative 6, minus 6 over p minus 5. Can someone who already did the problem verify with me that I did it correctly? Thank you. There's a lot of 8:30 a.m. mental math happening there. Okay, any questions about number what? Numero uno. Okay, number 3. Factor each and find all roots. One root has been given. Sketch graph, blah, 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 blah. Okay, so I'm going to write the thing down here. Actually, no. I am going to write it down here, but I'm going to factor an x out. Notice that they all have an x in common. And then after I factor an x out, I'm going to say, okay, this root is negative 2, so that's the factor x plus 2. And I'm going to do a 3 by 2 box with the cubic that I have left and the x plus 2. X cubed, x squared, 2x squared, negative 7, negative 7x, negative 14x, 12x, 24. Okay, so at this moment, I have f of x equals, I have the x that I factored out. I have the x plus 2 that I divided by, and I have x squared minus 7x plus 12. And that is diamond and boxable, correct? Okay, well, it took a hot minute, but she's factored now. 0, -2, 3, and 4, and that's 4 single real roots. Okay, so I'm going to go up to my graph and graph 0, -2, 3, and 4. I don't know if I'm going to fit it on the screen. 0, -2, 3, and 4, we'll say. This is a degree 4, positive A. So where do I start? Up or down? Up, right? I missed one of my dots. It's fine. It's fine. That thing is end behavior, and both arrows are going up. Hopefully you guys are okay with me using f of x and y interchangeably. Don't get tripped up by that. Zooey mama, that was a long problem. You guys know what Zooey mama's from? Yeah. So good. So good. I'm afraid as a math teacher, I will always have the cheese touch. Just from the sheer fact that I'm a math teacher. All right. So we have lots of excitement today. Lots of excitement. If you guys could find a resource page in here, it's the one that says 9.1.2. This one, just find this in your packet and then scooch that off to the side. This is the one, if you need another second look at it. This is the resource page we're going to do in a few minutes. Scooch that off to the side and set this up. If you're already in the back here, this says low swing, walk fast. Low swing, walk slow. High swing, walk fast. High swing, walk slow. All right. 9-1, emergency. Nurse Nina rushes to the hospital with one hand on her clipboard and the other pulling a portable stand. Her bags of blood swinging from the stand are needed immediately in the emergency room for 3 patients. Man, if you weren't awake before, now you are. Nurse Nina is so intent on delivering the blood in time that she does not notice that one of the bags has a small hole in it and is dripping on the floor behind her. My goodness, this is a gruesome math problem. As she reaches the emergency room, she is horrified to see a small pool of blood beginning to form on the floor. Looking down the corridor from where she's done, she sees the trail of blood is dripped and notices it forms a very distinct pattern. What shape do you think the trail of blood has created? Okay, so I'm going to give each of your groups an IV bag. Let me introduce you to your IV bag. Okay, I hope you brought a jacket. Okay, and you're going to fill this with water and do 4 experiments. Okay, now Birkenstock problem. Okay. All right, so you're gonna have somebody with their notebook. You're gonna have somebody who's gonna hold the IV bag. You're gonna go to the water fountain and you're gonna take the top off of the IV bag. You're gonna fill it up with water. And then you're gonna close the cap. You're gonna definitely put your finger over the top of the hole in the cap. Are you with me so far? Okay. Now. Okay. This works best. So you're gonna do 4 experiments. The 4 experiments are the things that you wrote down. So the person with the IV bag is going to walk slow. What's the first one? Low swing, walk slow. Okay, so you're gonna hold it like this. Low swing means you just pull it out a little bit. And walk slow means you're gonna walk slow, and I would do it backwards. So like, whoa. And then what you're gonna do is it's gonna make a pattern on the floor or on the ground, and you're gonna sketch that into your notebook. So low swing, and then like a higher swing would be pull it out farther. Okay, now, the thing I need to tell you is, I've used these bottles for a couple years in a row. You're gonna have to report back to me if any of them are, if these IV bags are not, in tip-top shape. I have 1 replacement, and there's only 7 groups, I have 8 of them. So just let me know if there's an IV bag, issue. Also, try not to take forever. Also, it's freezing, so you won't, but it'll be fine. Just, quickly 4 experiments and head back. Because we have so much more fun. Whoever is the least worried about having cold water, the IV bag can be great. It's gonna be awesome. Okay, you guys, go ahead, head out, try to find us. Miss Rice's class is doing the same thing, so try to find a spot of concrete that is dry. If any of you have a faulty IV bag, come back here. I have an extra. Did you do it?
Yeah.
It worked?
Yeah.
It's too cold outside.
That's fine. It doesn't need to be long. I mean, I know today's not an optimal day for just throw it on the floor. We don't dry it out. You will dry it off.
I can see if I can get you real ID then.
No, no, I'm good. I'm good.
Why? There's
You like me supervising my class outside?
Yeah.
I'm doing a really good job of it.
I was coming because none of my wall outlets are colored. And I wanted to see if your wall outlets are colored. I checked my projector, that one works, but then the rest of if your screens are on.
My calculator are on. This one's good, but this one might be really good. Yeah. Assume that they're the only person in the world and unplug stuff that. And then go cover it in.
Because they didn't want to wait for them to cut it.
Right. You guys, put your IV bag over here on the floor.
It's cold.
Indeed.
It's a bionic couple can have holes at the bottom. But you can make it work though.
Okay. But it still, you
Yeah.
got, you got what you
It
needed?
still works.
Yeah.
Okay. I'll go with it for one more period, see if I can.
Are your ID bags with a fucking salad?
Yeah. I put a lot of time and effort into them, as you can tell. Oh,
It was okay. We still got the idea though.
you got the idea?
Yeah.
You can put your, IV bag over here.
Okay. It's a collector.
Do you think, Jacob, I should take the tack and like make the hole bigger on that one?
Maybe. Ours is like, there's like, not jumping a lot of water. Yeah.
I have a tack that I've been trying to use to not, hurt the teacher, but somebody stole a tack off my wall and I was so afraid I was gonna spit on it. Can you imagine doing that to a teacher? That's like a prank that people used to do. Really? I know. Probably these days it'd be like assault.
Yeah.
You can't do the same stuff you used to do, really. Okay, we'll see how that works for fifth period. You guys go ahead and, hopefully you got something like I got up there.
Oh.
So the low swing ones are supposed to be little waves. Walk fast is supposed to be close together waves. Walk slow is supposed to be far apart waves.
All of that.
I mean, yes.
When you're walking, you're listening to like
Do I have it backwards?
yeah.
Oh, I do. Oh, crap. I accidentally switched the words. Okay, here you go. Is that better? Faster is wider. Yeah. Wow. Mrs. Sauter, coffee, I need coffee.
I mean, no, somewhat.
I accidentally switched the words when I set up the notebook, apparently. Okay, anyway. So you probably had it right to start with, and I was totally wrong. So also right here, notice I've added some vocab, some wave vocab. So you probably learned wave stuff in science. And we share some of the same vocab. We use amplitude, the height of the wave. And in science, you'll hear wavelength and cycle and frequency to describe how wide it is. In math, we say period. So that's just some vocab for you to describe how wide they are. Are we really working on waves this chapter? Yes, we are. We're working on waves. But not just waves. Okay. Do you need it again? Well, mine's wrong. Okay, hold on. Let me fix it. So this is supposed to be like that, right? Because it went around in a loop. Yeah, it happens. It's because we're humans. Okay, fixed. Okay, now if you guys could find that resource page that we just marked. Just gonna make sure I don't accidentally use that. Okay, now I get to read you another story from the book. Okay, 9-10. Hurry, let's get there before the line gets too long, shouts Antonio to his best friend Renee as they race to get on the Screamer, the newest attraction at the local amusement park. Oh, look, everyone, I have built the Screamer for you over here on my desk. It has only been open for one day, and already everyone is saying it's the scariest ride at the park, exclaims Antonio. I hear they really had to rush to get it done in time for summer. Antonio whistles as he screeches to a halt in front of a huge sign that said, "Welcome to the Screamer, the scariest ride on earth." The picture on the sign shows an enormous wheel that represents the Screamer with its 100-foot radius. Half of the wheel is below ground level and a very dark, murky pit with water at the bottom. As the Screamer rotates at dizzying speed, riders fly up into the air before plunging downward through blasts of freezing air and sticky spider webs into the pit, where they splash with dark, airy water on their way back above ground. Hence why the spiders inside the Screamer. Renee and Antonio wait impatiently to get on the ride, watching passengers unload and unload. New passengers get on and strap themselves in as others emerge from the pit looking queasy. The wheel rotates 15 degrees to load and unload the next set of riders. As Renee straps himself in, he remembers Antonio's ominous words. I fear they really had to rush to get it done in time for summer. Oh no! Okay, so this is the first thing I've ever spray painted in my life, by the way. I learned a lot. You have to do a lot of very light coats. A lot of light coats. That's what I learned. Anyway, so here's the Screamer. And there's this little tab over here that says seat right here. And so this is where you get on. This is like the loading platform. And then kind of like a Ferris wheel, it goes 15 degrees, and then there's another seat where the next people will get on, and then 15 degrees, blah, blah, blah. Okay, so we are going to use an E tool to get us all of the height. So CPM has made us a Screamer here. And at 0 degrees, that's where you get on the Screamer. Over here, it's at height 0. Okay, so go ahead and go in your resource page. And at 0 degrees rotation, the height is 0 and the actual height is also 0. Okay, this will make sense in a minute. Okay, so now I'm going to rotate this 15 degrees. And the height is 0.259. Okay, so you're going to write 0.259 in the measured height, and the actual height is 25.9 because the Screamer has a 100-foot radius. So you move the decimal over 2 spots. Okay, are you guys okay with me now just going on the E tool and moving it around and you guys writing the numbers down and I don't have to go back and forth between this and the resource page? You understand what we're doing? Okay, so let's go back to the screamer. What does this have to do with waves? Just wait, just wait. Okay, so the next one's 30. So 0.5 and 50. Hold on. Area code 0.707 and 70.7. 0.866, 86.6. 0.966, 96.6. 100. What do you anticipate is going to happen as I keep rotating around? 105 degrees. What do you notice? It's coming back down, right? Okay, so at this point, we can say, okay, if it's starting to come back down, okay, now let's go to 180. So at 180, the seat's gone all the way around the streamer and it's back at ground level. And then what's the seat going to do? It's going to go underground. Okay. So what's going to happen when I go to 195? The height's going to be the same number, but it's going to go negative. Okay, then what do you anticipate is going to happen once it rounds down at the bottom of 270? So 270 is at the bottom, which you can't see because of all this zoom stuff. There we go. So 270 is down here at the bottom. What do you think is going to happen once it goes back around 270 to 285? Yeah, it's going to start, it's negative, but it's still going to come back up to the surface, basically. So it's going to still be negative, but it's going to start coming back up. Okay. And if I kept going, I could go 375, 390. It would just keep going around in the same circle. It just would be repeating this table all over again. Okay, so what we're going to do now is do our best to graph these coordinates down here. And you're going to see how this has to do with the ID bags, water bottles. Okay, so 0, 0 is right here. 15 degrees is 0.259. So it's just like right above the 0.25. 30 degrees is at 0.5. 45 degrees is 0.707. So that's like right underneath the 0.75. 0.866, 0.966, and then what? You guys see the wave that's starting to happen. So this is the person gets on the screamer, goes up to the top. And then what happens? It starts to come back down to the surface and it's symmetric. So the heights match. Okay, so now we're going to go negative. So negative 0.259, negative 0.5, negative 0.707, 866, 96, negative 1 at 270. And then it comes back up to the surface. Okay, here's the hardest part about the whole math problem. The AP art part. Oh no, I already screwed it up. How's your wave? How'd it turn out? I'm just lucky I got a erasable pen, that's all. So this is one cycle of this wave. So it means it went top, middle, bottom, middle. So this is one complete cycle of it. Its period is 360 degrees, which means that's how wide it is. And its amplitude is 1 because that's how tall it is. Okay, now after you made your wave, get your notebook back out. Okay, guys, so what we're going to do now is find the equation of the wave. Believe it or not, the wave has an equation. It's even graphable on your graphing calculator. We're going to do that in a second. But first, we need to figure out what the equation of the wave is. Okay, so transport your brain back to math 2. Sitting in Guinan, Miscellany, Knight, Cap'n. And you have this which trig function should I use to solve for y? Sine. Okay. So remember, so Toa, and sine is opposite over hypotenuse. So I have sine of 75 degrees equals opposite over hypotenuse. And y over 1 is just y, so I have sine of 75 degrees equals y. Okay, grab a calculator and find me the sine of 75 degrees. Make sure that your calculator's in degrees. Super important that it says degrees. It should be a familiar decimal to what we were just working on. Sine 75. Oh, 0.966. Okay, so if the sine of 75 degrees is 0.966, go back and look at my table at 75 degrees. What is happening to the 75 degrees to get 0.966? What did I do to it in the calculator? What did I do to the 75 degrees? I did the sine of it. Yeah, I did the sine of it. Okay, what that means is all of these numbers are the sines of these angles. You could try any of them in your calculator and you should get this number. So sine of 150, 0.5. We just created a table basically of sine of all of these angles. Okay, which means that the wave has an equation of y equals sine of x. Okay, now a lot of times you're going to see that written y equals sine of theta. We need to talk about that. This guy here is a Greek letter theta, which we use for angles a lot of times. So sometimes when you're doing these problems, you're going to have an x there. Sometimes you're going to have a theta there. They mean the same thing, but theta is usually reserved for angles, which you probably already knew from law of sines and cosines and stuff. Okay, so for B, I want to graph it on the graphing calculator together. But we need to work on our window. So what I want to do is I want to take the window of this and make it match my graphing calculator. So if you hit the window button, which is right next to the y equals, we want to make these things match the window of this. So our minimum x is going to be 0 because that's this spot right here. So x min is going to be 0. The x max is going to be 360. And the x scale is going to be going by 15. If you notice your scale on your graph here goes by 15. And then your y min is -1. And your y max is +1. And your y scale, what's the y going by? The boxes on the y graph, 0.25. Okay, so you're going to do two things. You're going to go to y equals and put in sine of x. And then you're going to go to the window button, which is right next to the y equals button, and you're going to make it match this. And then when you're done, hit the graph button. Oh, satisfying. Okay, now I want to remind you that Zoom 6 will always get you back to the original window. So you don't probably want to graph everything in this window for your life. So if you hit Zoom 6, you'll get back to the 10 by 10. Look at how not exciting that is when your window's not set. You can sort of see the wave a little bit, but it's not nearly as cool without the window set up. Now, if you guys have ever been staring at my all you need is love poster over here, that bottom one, the E, might make more sense now. So interestingly enough, I have people in here that can probably understand it. This was a sine wave. The X and Y are flipped, so it was inverse, which means it went on its side, up and down, and then the absolute value made it all go on to the left. Pretty cool. Pretty cool. Okay, last problem. If you guys could get the next resource page out. You guys even know that sine, cosine, and tangent had graphs? Okay, now for this graph, I highly suggest you have a ruler. If you do not have a ruler, you might want to go grab one. Okay, just to hit this home, we're going to do this one more time, and we're going to relate the screamer to the wave. So the screamer is on the left side. By the way, it's not actually called the screamer, it's called the unit circle, but screamer is so much better. So the screamer is on the left side, the wave is on the right side. And what I want to do is make sure that we're all completely connecting these two things to each other. So first thing I want you to know is this is 0 degrees rotation right here. This is where you get on the screamer. So you get on the screamer over here. Okay, now you rotate up 15 degrees. How high are you? Think about your table that we just did. How high are you? Yeah, 0.259, 25 feet. Okay, so what I want you to do is take your ruler, and each one of these notches is 15 degrees. So try to line up your ruler, the height of the 15-degree triangle, with the very first notch. And then you can also put a dot at your start when you're at ground level. Okay, then we rotate up to 30 degrees, which is very conveniently at 0.5. Might actually be easier to do that one without the ruler because you've got the tick mark. Then rotate up to 45 degrees, which is 0.707. We all remember that one in this county. Then 60 degrees, I believe, was 0.866. And then 0.966, I just put this one like right underneath the line. And then the 90 degrees is right at the top at 1. It's important to note that this is 90 up here for sure, but it keeps rotating. It keeps going by 15 degrees. I'm not going to draw the whole thing in, but you need to know that it keeps going. And each one of these tick marks is symmetric. So at this point, you can use your ruler, try to line it up. That's terrible. Might be easier without, I don't know. Okay, then it keeps rotating. This is 195. But this is where it starts to go underground. So you're going to hold the ruler underneath, which I actually think is quite a bit easier. Negative 0.5. Negative 0.707. Eight six six 966 -1. And then it starts coming back up to the surface. Okay, and this is one of my favorite moments of this lesson. I'm actually pretty much done, but I want to blow your mind with something. Did you ever wonder why the quadrants were named the way they are? Okay, think about 1, 2, 3, 4. The quadrants are named the way they are because of the screamer. Because you rotate through quadrant 1, then quadrant 2, then quadrant 3, then quadrant 4. So if you ever wondered why they're named that way, it's because of this rotation of the unit circle. There are a couple of skills that are really helpful for chapter 9. First one of them is spatial awareness. What I mean by that is how far an angle is open, basically. If it's acute or obtuse, how many times around 360, that sort of deal. The second thing, that's usually not a big deal. The second thing is fraction. There's a lot of fractions in this chapter. So you need to know that like 1 is 12/12. And 1 is also 4/4 and 6/6 and stuff like that. Don't worry, we're gonna practice a lot, but anyway, so that is it. My exciting lesson about IV bags and scary roller coasters. Also, did we decide in this class that absolutely no one watched SpongeBob? Not even one of you? We decided that, right? No one. Like, I just feel like I really want to call this the fiery fiscal pain.
Yeah, I can't tell you the reference.
The fiery fiscal pain is like the scary roller coaster that SpongeBob and Patrick go on, and everyone's like holding their spines when they come off. Yeah, yeah. Okay, I do have a joke for you too. Oh man, just full of it today. Okay, so our goal for today was to graph the sine function. I think we did. Number 1 was water bottles, and 10 through 12 is about the screamer. Homework is 4 problems, 13, 16, 17, and 21, and I made you a sine wave. Can you imagine the fun that happened when I went to search sine wave jokes and Pinterest? It was good stuff.